The universe started in a Big Bang. That's the prevailing theory, at least. There are a few other ideas out there, but scientists are pretty confident that that's how the universe started. The end of the universe, though, is a bit more mysterious. Let's jump right into the first theory, the heat death of the universe. This one, in my opinion, is the scariest. Basically, the idea is that as the universe continues expanding and stars burn out, the universe will eventually go dark. The overall heat of the universe will asymptotically approach zero. That just means that as the age of the universe approaches infinity, the temperature will approach absolute zero. It's impossible to ever reach infinity, that's kind of the whole idea of infinity, so the temperature of the universe will never actually reach zero, but it will get really, really close as the universe continues to age. How is something like this even possible? The second law of thermodynamics says the total entropy of an isolated system can only increase over time, moving towards a state of maximum disorder. Okay, so what the heck does that mean? Basically, that in every reaction, a little bit of energy is lost as heat. Let's take a look at car engines for a second. Engines take gas and turn it into movement, or to put it in millennial speak, go-go juice goes in, and then your car gets the zoomies. But what's actually happening here is that the engine is turning the chemical energy of the gas into kinetic energy. This process is pretty inefficient though. Most engines operate at about 20 to 35% efficiency. That means that only 20 to 35% of the chemical energy in the gas is being converted into kinetic energy that can move the car. The other 65 to 80% is lost as heat. Plus, there's friction between parts and between the wheels and the road, so the actual energy loss is a little bit higher. And that inefficiency in the engine and in the transferring of energy is why motors get so hot, and why a car with a damaged or missing cooling system can pretty easily overheat. Just as an interesting side note, electric cars have about 87 to 91% efficiency, and that's why it's a little bit cheaper to power an EV than it is to buy gasoline for your car. And this energy loss is happening in every system. When your computer or phone uses energy to show you this video, some of that energy is lost to heat. When your body digests food to make ATP, some energy is lost as heat. Then when you use that ATP to go for a run, again, energy is lost as heat. That's part of the reason why you get so hot when you exercise. Anytime energy is converted from one state to another or used in some way, some of it is lost as heat. Now, let's scale things up from cars to stars. Anytime anything happens in the universe, the overall entropy level goes up. Less and less of the universe's energy is available in a usable way, and is now just kind of out there floating through the void. And as the universe expands more and more, the overall density of energy will go down. Stars will get further apart, and galaxies will eventually vanish. At 100 billion years out, we wouldn't be able to see any stars in the sky. Now, we only have about 5 billion years until our sun goes out, so maybe we should worry about that first. Then, in about 1 trillion years, we wouldn't have stars anymore. The last of the stars will die, and galaxies will be so far apart from each other that it'll kind of be like they don't even exist. No new stars would be able to be born either. The gas needed to form new stars would be all used up. At 10 to the 65 years out, black holes would start vanishing. They would evaporate through Hawking radiation. Hawking radiation is basically just a kind of radiation that black holes give off that causes them to slowly shrink over time. I could make a whole other video about black holes and Hawking radiation. It's a really complicated and interesting topic, so if you want to see that, let me know in the comments. As the last of the black holes vanished, we would truly be at the heat death of the universe. Everything is so spread out and dissipated that nothing would ever happen. A pretty grim future, to be sure, but not one we really need to worry about. This would be so far in the future that, as far as we're concerned from a human perspective, it's basically never going to happen. There are some other nuances here, like the Poincare resurgence theorem and fluctuation theorem, that, if correct, could mean scenarios in which the overall levels of entropy could go down, but that probably wouldn't be enough to stop the heat death of the universe, especially if there's enough dark energy. Okay, so universe ending number 2, the Big Rip. You just heard me mention dark energy, but what actually is that? Well, to put it simply, we aren't really sure. What we do know is that there's some kind of energy out there that's causing space to expand, and that the rate of expansion seems to be accelerating. There are a few ideas about what dark energy might actually be. One theory suggests that it isn't energy at all, but just an intrinsic property of space. Space makes more space, and then when there's extra space, that space is making space too, so the more space there is, the faster space is made, thus the accelerating expansion of the universe. Another idea is that empty space is actually full of virtual particles. Getting into virtual particles and some quantum weirdness isn't really within the scope of this video, but the short explanation is that virtual particles aren't actually particles, but fluctuations in quantum fields that are thought to carry forces throughout the universe. The particles are constantly coming in and out of existence, and that process is what's producing dark energy. As with the last theory, when there's more space, that would cause the expansion to speed up. The more space there is, the more room there is for these particles to show up and disappear and speed up the process. I hope that explanation made sense. Quantum physics is really weird, and I honestly don't really understand it all that well, but I don't think anyone really has a full understanding of it. Now, I'm not going to get into every idea of what dark energy might be, simply for the sake of time, but there is one last one that I want to talk about, and it's even weirder than virtual particles. Dark energy could be created from some kind of field that is present everywhere in the universe, kind of like the Higgs field. This field would have the opposite physical effect on matter. So instead of gravity pulling everything together, this field would create a kind of anti-gravity that's pushing everything further apart. This could help explain why dark energy is stronger in empty space. The pull of gravity, in the normal way, is strengthened when there's more matter and when that matter is closer to each other. So it would make sense that this field that's creating this kind of anti-gravity, or dark energy, would work in the opposite way, meaning there would be more dark energy when there's less matter, and that matter is further apart from each other. So empty space would create more dark energy. This would also help to explain the accelerating expansion. Honestly, when I started researching, I didn't really like this theory that much, but the more I dove into it and kind of understand it, the more I'm kind of like, yeah, this one kind of makes the most sense to me. All of that's to say that the universe is expanding and that expansion is accelerating, but we aren't really sure why. Don't freak out though, we don't really need to worry about that expansion here on Earth. Gravity's keeping everything together here. Our planet is held together by gravity, our star system, even our galaxy are all held together by gravity. The only effect on Earth that we can really see is that distant objects are getting more distant. And besides, that expansion isn't fast enough to counter the forces of gravity. Well, at least not yet. The theory of the Big Rip is that eventually the expansion will become fast enough to outpace gravity, and it'll start ripping the universe apart. In fact, some might say that distant objects getting more distant is just the early signs that this will happen, or maybe it already is happening. The end of the universe will start pretty slowly in this scenario. It'll actually start with what we're observing now, space getting bigger exponentially. It'll continue speeding up, and eventually, as it speeds up, it'll be enough to start ripping galaxy clusters apart. As the expansion speeds up further, it'll start ripping smaller and smaller things apart. We would see galaxies start coming apart and spitting off stars just randomly throughout space. The same thing would happen to star systems. Planets would fall out of orbit and just fly off into space. The dark energy would become so overwhelming that planets and stars would start ripping apart as well. Eventually, everything would be broken down to smaller and smaller parts. As the dark energy overtakes the power of fundamental forces, atoms themselves would break down, and we would end up in a pretty similar state as the last scenario. A cold, dark, mostly empty universe. But what would happen if dark energy isn't strong enough? Well, thankfully, we have a force that could help hold everything together: dark matter. Now, it might sound that dark matter and dark energy are similar. After all, they both are dark. But in this case, dark basically just means invisible. Neither of them interact with light or the electromagnetic spectrum, really, in any way. So, how do we know that they're out there? Well, we can see the gravitational effects that they have on the universe. We've seen patches of space where light bends in ways that we think it shouldn't, based on what else we see nearby. The only answer we can come up with is that there's invisible matter and invisible energy out there that are having an effect. We can't see or interact with dark matter or dark energy, but that's where their similarities end. Dark energy is causing the universe to expand, but dark matter is holding things together. And it's estimated that it's actually about 85% of all matter in the universe. Now, if the gravity created by dark matter and traditional matter is enough to overcome the power of dark energy, then we would eventually see the universe's expansion slowing down, then stopping, then the universe would start coming back in on itself, and eventually end in the Big Crunch. And that's theory number 3 about how the universe might end. I found one paper that suggests that this will happen when the universe is about 33.3 gigayears old. That's 33.3 billion years. That same paper estimates the universe is about 13.8 billion years old. So that means we're about 40% of the way through the universe's life cycle. Maybe that's why so much craziness has been happening recently. The universe is just going through a midlife crisis. I mean, I know if I only had 20 billion years left, I'd be freaking out too. The same paper also suggests that the crunching phase would only be about 25% of the universe's lifespan. So we still have a bit of expanding to do before we start shrinking back down. Now, there are a lot of factors and things that we aren't really 100% sure about, such as dark energy fluctuation, or what dark energy or dark matter actually are. So this isn't a for sure thing, but based on what measurements we can take and a ton of complicated math, this is probably a fairly accurate estimate, or at least the best approximation that we can do so far. So what exactly is going to happen in 20 billion years? Well, it's basically gonna be the reverse of the Big Bang. The universe will get smaller and smaller until everything is in a single point, and then that'll be it. Universe over. But not necessarily. While some people think the universe will just end there and be done forever, others think that it might be part of a natural cycle. The fourth theory I want to talk about today is the Big Bounce, and this one's my favorite. The idea here is pretty much the same as the Big Crunch, but instead of the universe ending, it's reborn. Basically, the Big Bounce hypothesis says that after the universe collapses in on itself, it would be in the same state that it was before the Big Bang, and thus be ready for another Big Bang. If the Big Bounce hypothesis is correct, and in my humble opinion, I kinda think that it's the most likely option, then our Big Bang was only possible because the universe before us had a Big Crunch. And when we have our Big Crunch, it would give birth to a new universe again. The universe would continue on like this, potentially forever, birthing a new universe every time the old one dies, like a phoenix from the ashes. Now, if I'm being honest, this one isn't just my favorite because I think it's cool, and it definitely is pretty cool. But this one's actually my favorite because I find it the most beautiful. Every ending is a new beginning, and every beginning is birthed from old matter and space-time being reused. Which, speaking of space-time, I would be really interested to see how space-time actually behaves in a Big Crunch. Movement through time is linked to movement through space. So, does that mean that we would live in reverse once the universe started shrinking back down? Probably not, but it's a fun thing to think about. And one thing that none of these hypotheses talk about is where all this matter and space-time came from in the first place. I mean, that's not really what this video is about, but where did everything come from? To me, it just makes more sense for nothing to exist, so why am I here thinking these thoughts and making these videos? And I think for us to really understand the ultimate fate of the universe, we would have to know more about the origin of the universe and what was there before the universe. But that's another thing that we don't really have a full understanding of. Now, there's a lot of math and science behind all of these scenarios, but we still aren't totally sure what's going to happen. There's simply too much we don't know about the universe and about the contents of the universe, including dark matter and dark energy. Maybe there's even dark time out there. I don't know. But I sure have enjoyed this journey to the end of time with you. If you thought this was fun and you learned something new, go ahead and give me a like and subscribe. I'll see you guys next time, and remember to stay curious.